Hi, you have seen me traveling around the world, checking their electrical systems, in particular, their ground fault protections. And yet, at home, here, I'm living with a broken GFCI outlet. I have been living here for 4 years and this has been failing since day one. What shame, what embarrassment. I thought I knew better. I thought you knew better, but we don't. No worries, we can rely on my sponsor Brilliant.org because it's the best place to learn and refresh your math, science or computing knowledge with well-produced and interactive courses and quizzes. Sign up using my link Brilliant.org/ElectroBOOM and use the 30-day free trial and you'll see for yourselves. Or at the end. But back to this thing, you might ask, why did I keep it around for so long? Am I not worried about my family's safety? Well, it doesn't work right, but in a safe way. See, it pops open without anything plugged into it. I can pop it back in, plug in an iron, and use the iron just fine. See? But then, oh, see? It pops at random times. Well, I popped it just now off camera because it pops at random times. And that's not the only problem. After it pops, it keeps popping again and again at random times. How does a breaker even pop after it popped once? And it's just, oh, see, it just popped. Oh, sorry, that was just a fake sound effect I played there. What can I do? It doesn't pop very often. I'm not a National Geographic wildlife photographer that can sit there for hours trying to capture an event. The defective outlet sits quietly and bides its time so it can pop again and again away from onlookers. Yeah, this one was also fake. Trust me, it pops. The only inconvenience is the noise and the fact that every time we need it, I have to pop it back in. Otherwise, it pops correctly every time there is an actual ground fault. Right? I mean, when I press the test button, it pops out, so I assumed, what if it is tricking me? Let's do the usual test. This is a 22 kilo ohm resistor that on 120 volt AC creates more than 5 milliamps, enough to trigger these GFCI devices. And I've said it 100 times, a ground fault happens when current, instead of running from live to neutral, runs from live to earth or somehow neutral to earth. And that's illegal. It indicates there is a problem, like current is running from live through some person to earth. So don't do it like I do. We open the doors like this and we connect a resistor between live and earth. This should be safer. Let's try again. And place the resistor between live and earth. Oh, see? It popped. So it works fine. I have a replacement GFCI to replace this and I'm planning to dig into this and learn about its circuit and see if I can fix it. Now, taking the GFCI out is safe because in case of accidentally touching the live, it pops open and protects. It is important to know that a GFCI device protects its output and the input we are trying to disconnect comes straight from city without any protection. Because we don't live in Europe and don't have central house ground fault protection. If we look at the back of the device, we see that these two are the unprotected live and neutral input to the device. And this is earth and the device protects its outputs. And it also outputs the protected live and neutral here that with earth you can connect to other outlets and have multiple outlets protected. Well, here we are not protecting any other outlets. We just have to disconnect that. And I can see the line voltages are connected to the right input. This must be defective, it pops so much. Okay, it's good. That's not how we check it. Nice, now I have to work in the dark. I guess it's safer this way. There we go. Hot goes here, neutral, and earth. Screw it back in. Works. I think my resistor is a dead short now. Let's bring another one. Yeah, it welded itself to my plier. damn it. It's always beneficial to make sure your resistor is healthy first before doing such tests. Oh, popped. It works. Now I guess we'll see if it randomly pops like the old one, which I don't expect it. If it does, it must be some other magic going on inside the wall. Okay, this has been sitting here for 2 days now and hasn't popped once. The old one is definitely defective. Let's connect it back to power and see what's going on. I suspect there might have been some noise on the power lines and this is too sensitive to it. It's powered and dangerous now. Oh God. Okay. Seems like it's working. Let's make some noise with this and see if it pops at all. Aye. Don't hit me. Damn it. Aye. Oh, it popped. Did I hit live? How about the output? Neutral? It's not popping anymore. Maybe I got lucky and captured one of those random pops just now. Let's test it with the resistor first. So this is the live and neutral output of the device. And if I connect my resistor between earth and live, oh, yeah. It pops. I've heard if you run current from neutral to earth, it should also trip the GFCI, although neutral and earth should be shorted together at the fuse panel inside the house. Because equipment and appliances run current through neutral, but there is no current running through earth. Because of the resistance of the wires, the voltage difference between neutral and earth gets larger further inside the house. For example, in my room, if I measure the voltage between neutral and earth, I see it's around 0.8 volt AC. So if I short between earth and neutral, there should be enough current to, there you go, trip the GFCI. Let's open it up. Kind of broke. Damn it. Well, I bent it. Why does it have so many bits and pieces? I have no idea how these mechanical contraptions work. It just jumped out at me. I think I've lost a bunch of springs too. More bits and pieces. This is some complicated assembly. I don't know if I can put it back. You see all these components? It seems like they covered them here for humidity perhaps. How does it even work? I think I have to wire it back up. Now, how do I power it up without killing myself? Snow gloves. Better than nothing for house level voltages, as long as nothing pokes through them. Now we plug that in, and it seems safe. It's interesting, there is no earth connection to the board. How do you trip this thing? Well, it's tripped already because the light is on. How do you untrip it? Wait. What is that? I have no idea how anything works in here. It's so mechanical. I'm sure this button goes here and it should reset it, but it doesn't stay reset for some reason. I don't know what's going on. Oh my God, why is it smoking now? Come on, come on. I guess it's a game of puzzle now. Missing a spring there. Where's the damn spring? All right, these are those tiny doors that go in front of live and neutral to close it to the outside wall so nobody can stick a fork into them. This is a light guide. Another light guide? But we don't have any other light. I figured it out. See if you can keep up. So this is live and neutral input that goes to the output here through these contacts, and if you push these down, it disconnects from the output. Now there is this bit here with this springy thing and this button pin that resets the breaker. It is designed to go in here and get trapped in this springy thing, and the way to disengage this pin from that trap is to push this back so it releases and comes out. And then there is this piece of plastic that goes over the contacts here. A spring in this thing pushes this down, disconnecting the contacts. Okay, so this bit thingy has also a flat thing at the end here that we can push back. Pay attention! This thingy goes in first like that, and there is this solenoid that was buzzing and smoking earlier. See this solenoid, when it's energized, it pushes against that spring thingy there, pushes that back and releases this pin. So that bit goes in there, then this piece of plastic goes on top, and this spring pushes down on that, disconnecting the contacts. Okay, contacts are disconnected now. Now this pin also has its own spring that pushes it up. If I push this down, it will get caught in that bottom pin there, and this spring is stronger than the other spring, pulling this button up. Let me show you. So this pin gets trapped in that bottom pin, and its strong spring pulls the whole thing up like this. Well, not all the way out like that. But when it pulls it up, it disengages this plastic from those contacts, so these contacts can connect and the power connects. So in case of a ground fault, this solenoid is energized that pushes against that spring, releasing this button that in turn allows that plastic to push down on those contacts and disconnect them again. Or the test button uses this clear piece of plastic to push this thing down. It pushes those contacts down, that energizes the solenoid again, as you saw earlier that it smoked. Are you with me? Now the electronic part is the more interesting part. Look at this. The actual live and neutral go to these contacts that go through this device, which is basically a current sensor. See, they go in from the bottom and come up straight from the top here, going to the rest of the circuit. And that thing is basically a coil around the live and neutral wires. Both live and neutral run through it at the same time. See, when both live and neutral wires run through a sensing coil, and if they are connected to a load, their currents are always equal and opposite each other. So their magnetic fields cancel each other and the sensing coil doesn't sense anything. But if one of these wires leaks current somewhere else, like to Earth, then their magnetic fields are not equal and don't cancel each other, and the sensing coil picks up something telling us there is some illegal current. For example, I have my clamp current meter here that it's 0 is not 0 already. And if I pass 10 amps of single wire through it, oops, you see, it's reading 10 amps. But if I instead run both wires through it, like, come on, this, because both currents are equal and opposing each other, the magnetic fields cancel each other and we see around 0. We can create an imbalance between the currents of the wires by sending some of the current from outside the loop back to the source. And suddenly, the current reading is not 0 anymore. And this thing is sensitive enough to detect 5 milliamps of imbalanced current among the 15 amps of full current it can deliver. And the rest of the circuit just measures and detects the imbalance between live and neutral currents and basically energizes this coil with a bunch of mechanical mumbo jumbo. Now, I bet I can put it back together. What do you think? Will it go on now? Back in one piece! The question is, does it work? Let's plug it in. Seems fine. Let's reset it. Seems like it's working. Is it actually powered? No? I put in something wrong. Did I put this on backwards? Yeah, I think so. It should be the other way. Trying again. Oh, stuck down. Powered? How about the reset button? Tripping with the resistor? Fixed it! Oh! I forgot to fix it! Well, there was too much of a complex circuit in there to figure out what is marginally failing. But what I've noticed is that a lot of times when I just open and close something, magically it starts working fine afterwards. So I have that going for me. Well, it works. And I did find the knowledge of current sensing part quite interesting. It works. Well, of course, I just scratched the surface of how this thing works, and the actual design of this requires much more knowledge of physics around the components and sometimes complex calculations. You can use my sponsor Brilliant.org to make a great foundation for such knowledge. There are thousands of interactive lessons in math, data analysis, programming, AI, and many more fields of study at Brilliant, where you learn by doing and interacting, changing parameters and seeing results. And that's the best stick-in-your-brain type of fun learning everyone needs, not just reading boring pages of numbers and graphs. Imagine a book where you could change numbers and figures. Instead of just memorizing, you build skills to change and troubleshoot. Did I mention data analysis? Because that's one of the most important tools of any research and design work. I used to pull a ton of data from my tests and research and be like, what do I do now? I would have benefited from all the new data analysis content at Brilliant on how to parse and visualize data and make it easier to interpret, learning by working with real data from sources like Starbucks, Twitter, Spotify, and more. There is no commitment. You can use the 30-day free trial signing up from my link brilliant.org/electroboom and learn for 5 to 20 minutes every day at your own convenience. Warning though, learning there pulls you in like a fun game. But no worries, you get 20% off Brilliant's annual premium subscription using my link. Do it! And thank you for watching.